Welcome to the DIY Honda Garage channel. The DTC P0133 indicates a malfunction or slow response of the air-fuel AF ratio sensor 1 in the Honda CR-V 2023 and newer models. This diagnostic trouble code suggests that the powertrain control module, PCM, has detected an abnormality based on the responsiveness of the monitored sensor value over a specified duration. The AF sensor 1 is critical as it measures the oxygen levels in the exhaust gases to optimize fuel combustion. Its role ensures the engine runs efficiently, helping to meet emission standards and improve fuel economy. Located in the exhaust system, typically before the catalytic converter, the sensor directly communicates with the PCM to adjust the air-fuel mixture. If the PCM continuously observes slow responses from this sensor, it will trigger the DTC, indicating a need for further diagnostics and potential repairs. The AF sensor 1 is responsible for measuring the concentration of oxygen in the vehicle's exhaust gases, which is essential for maintaining an optimal air-fuel mixture for combustion. This component plays a pivotal role in ensuring the engine functions correctly and efficiently, ultimately promoting better performance and lower emissions. Generally, the sensor is situated in the exhaust manifold or downpipe, just ahead of the catalytic converter, making it instrumental in monitoring exhaust gases before they undergo further processing. If this sensor malfunctions or shows a slow response, it can lead to poor engine performance, increased fuel consumption, and elevated emissions. The PCM relies on accurate readings from this sensor to adjust fuel injection parameters. Thus, recognizing and rectifying issues related to this sensor is key to maintaining vehicle health. Various reasons can lead to the triggering of DTC P0133. First and foremost, a faulty AF sensor 1 is the most probable cause, as it directly affects the PCM's ability to monitor the air-fuel mixture accurately. A breakdown within the sensor itself can lead it to provide incorrect values or show a slow response time, resulting in a malfunction notice. Second, wiring or connection issues can impede the sensor signal to the PCM, such as frayed wires or corrosion in connectors, which can disrupt communication. Lastly, although less common, a failure within the PCM itself can result in misinterpretation of the data received from the sensor, leading to the indication of a defective sensor. All these potential causes warrant a thorough inspection to isolate the issue correctly. Drivers may notice several symptoms correlated with DTC P0133, all of which signal a deterioration in vehicle performance. Reduced engine performance is a common sign, characterized by sluggish acceleration and hesitations during operation, caused by an improper air-fuel mixture. Increased fuel consumption may also be experienced, as an inefficient combustion process leads to the engine using more fuel than necessary, negatively impacting fuel economy. Additionally, illumination of the check engine light is a significant indicator that an underlying issue exists, prompting the driver to perform diagnostic checks. Furthermore, other performance-related issues may arise, such as engine vibrations and rough idling due to the improper fuel mixture resulting from sensor failures. The initial step in troubleshooting DTC P0133 involves starting the engine and maintaining its speed at 3,000 RPM without any load, either in park, P, or neutral. This action is critical as it allows the engine to reach optimal operating conditions while ensuring that the AFAT sensor is responsive. During this phase, the technician should monitor the engine closely and observe the RPM gauge to ensure accurate speed maintenance. The objective here is to allow the intake and exhaust systems to stabilize, leading to consistent readings from the AFAT sensor. Ensuring the radiator fan comes on is key, as this indicates that the engine has reached a certain temperature threshold, thus influencing the engine's air-fuel ratio. This effective preliminary action sets the stage for subsequent diagnostic procedures. In the second step, the focus shifts to test driving the vehicle under specific conditions to evaluate the AF sensor's performance further. The technician must verify that the engine coolant temperature ECT sensor 1 reading exceeds 158 degrees Fahrenheit, 70 Celsius, as this threshold indicates the engine is sufficiently warm for accurate readings. During the drive, the transmission must be engaged in Drive D mode, with the engine speed consistently maintained between 1,500 and 3,000 RPM. This state helps mimic real-world driving conditions. The speed should be controlled at 25 miles per hour, 40 kilometers per hour, or less for the initial 5 minutes, allowing the exhaust gases to stabilize. Following this period, it's crucial to accelerate and maintain a speed of 26 miles per hour, 41 kilometers per hour, or more for at least 8 seconds. This step is vital in capturing the AF sensor's response during changing driving conditions, reinforcing the diagnostic evaluation. The final troubleshooting step entails monitoring the Honda Diagnostic System, HDS, for the onboard diagnostic, OBD, status that pertains specifically to the powertrain control module. At this stage, the technician should carefully observe the HDS display for the presence of DTC P0133. If the code persists, it suggests that the prior diagnostics did not resolve the underlying issue, indicating further investigation is necessary. Confirming the OBD status effectively helps in diagnosing whether the AF sensor is responsive or if there are other complications with the PCM's interpretation of the readings. Ensuring that the system reflects accurate diagnostics is crucial for concluding the assessment and proceeding with necessary repairs or replacements. This comprehensive monitoring phase validates the earlier troubleshooting efforts. Upon completing the necessary repairs or sensor replacements for DTC P0133, the next phase involves a conclusive verification step. The technician must clear the diagnosed DTC from the PCM using HDS, resetting the system to test if the issues are effectively resolved. Following this action, a thorough recheck must be performed, watching for any reappearance of DTC P0133. If the error code does not reappear, it is an encouraging sign that the underlying issue has been addressed appropriately. This verification process reassures the technician that the A/F sensor is functioning correctly and that communication to the PCM is restored. Ultimately, successful verification confirms the restoration of optimal vehicle performance, which is essential for driving safety and efficiency. To prevent future occurrences of DTC P0133, implementing effective preventive maintenance routines is vital. Regular checks of the AF sensor and surrounding electrical connections ensure that any potential degradation or wiring issues are identified early. Additionally, maintaining a healthy exhaust system plays a crucial role, as any leaks or damage can adversely affect sensor readings and overall engine performance. Keeping contacts clear of corrosion and damage mitigates risks to sensor efficiency, fostering a reliable system. Regular servicing and diagnostic assessments can preempt sensor-related issues, ensuring the vehicle continues to operate smoothly. Taking these preventive measures not only promotes engine efficiency, but also helps maintain fuel economy and aligns with emissions regulations. In conclusion, understanding the role of the A frequency parameter is paramount when addressing DTC P0133. This sensor's functionality is crucial for maintaining efficient engine operation and optimizing fuel combustion. Recognizing potential causes such as sensor failure or wiring issues is essential for accurate diagnostics. Engaging in thorough troubleshooting procedures, as outlined, allows technicians to methodically isolate and resolve issues related to the air-fuel ratio. Lastly, ongoing preventive measures contribute significantly to vehicle reliability, avoiding the pitfalls of similar codes in the future. By fostering an understanding of these dynamics and committing to diligent maintenance practices, drivers can ensure their Honda CR-V continues to perform at its best. Please like and subscribe to the channel. See you next time.